So hi, everybody. And yes, I'm Guy Podjamy, or Guypo, and I'm going to talk to you about stranger danger, about the risk in pulling in the sort of NPM packages that we know and love. So a little bit about me, just for context. I am the CEO and co-founder of Sneak. Before that, I founded a company called Blaze, which Akamai acquired in the performance space, and was CTO at Akamai. And prior to that, I worked for about 15 years in security through some parts in the sort of Israeli cybersecurity parts of the Israeli army, as well as working on application security when it was still new. And I had to explain what SQL injection is and why you should care. So with that, let's sort of dig in. So NPM is awesome, right? NPM is awesome, and we all love it. It's a natural aspect of how we develop in Node, and really, it's kind of hard to imagine the Node space without NPM kind of at our fingertips to use to sort of bolster our productivity. And as a result, NPM usage has exploded, and these are, every time I do this deck, I need to update the stats again from the NPM website, just because the numbers are exploding, right? The number of packages, the rate of downloads, it's just a ridiculously large number and growing at a insane pace, which I'm sure makes Mati very happy. So you can sort of say JavaScript as one, definitely in terms of like speed of growth and reach of the community, it definitely has. And it leads to the situation where a typical Node application has hundreds, if not thousands, of different dependencies. I was just working with one of our users who has about 1,000 unique dependencies in a 14,000 node dependency tree. And that's fairly common. It's not maybe the norm yet, and some of those are direct. You pulled in some, a few dozens maybe directly, but many of them are indirect and just sort of get pulled and become part of your application. So it leads to the situation where this is your app, and this is your code. And like at a glance, you might think this is a negative slide, but I actually think of this as a positive slide, right? It means you could create all that value, all that orange-ish value, by just writing the purplish lines of code there. So you can produce a ton, but it's also kind of scary. Each one of these dependencies, these packages, is a piece of code we pulled in, and with it, we pulled in some security risks. First of all, do you even know which dependencies you have? So for starters, what code and whose code are you running? Do you know, for every one of these packages that you pulled in, if the developers building it had any sort of security expertise? I mean, many of these packages are built by 1, 2 people, and it's far less likely that every individual would have that type of security expertise than a team, sort of a large team of people in which it's more likely that somebody would have some security experience and expertise. And similarly, do you know if it underwent any sort of security testing? Security tests or security tools tend to be pretty expensive, hard to use, and again, small 1 to 5 person teams that are building an open source package oftentimes do not have access to those. And a little bit more practically, and I'll get back to this in a moment, is do you know if they have known vulnerabilities? Like clearly, packages have bugs. This is software. Software has bugs, as we just discussed. And some of those bugs are security bugs. And they present flaws, but some of those are reported. Some of those you could know about. So this is the software part of it. And then the other aspect is that open source is written by people, and we like to celebrate that, right? It's great. We have a community. It's an amazing community, especially in sort of the Node space. But it's sometimes easy to forget that these people are not people we know, and they're strangers. And when you think about the fact that you're pulling in code from the internets, right, just from somewhere out there, and you're running it in your production, high volume system, that's a little bit scary. And while we like to think that everybody's sort of a benevolent pony, some are not, right? There are bad actors out there, and they're a very small fraction of the community, but they do exist, and we have to sort of be conscious of it. So what do you know about these contributors, right? And again, same questions. Do you know if any of them were malicious? Do you know if any of them were a little irresponsible with how they maintained their development environment and got compromised? We've seen some of this in the mobile space with Xcode Ghost in iOS, and there was a recent vulnerability in the Play Store. In both cases, attackers attacked targeted developers and then tried to inject malware into the applications that those developers produced to, at the end of the day, compromise the victims, the users of those applications, which means the developers were really just a distribution vehicle, right? Us, we are a distribution vehicle for attackers because one compromised developer equals many compromised clients. So this is a big problem. There's no solution. I don't have a silver bullet here to say, OK, this is a concern. And I also think that this is a community problem, and we need to have more conversations about it. But in this talk, I'm going to focus on a very concrete step about it, which is known vulnerabilities, these known security bugs, which are a good way for us to get started at accepting there are security threats in this methodology we adopt and taking them on. So I'll focus exclusively on NPM, which is sort of my space, although this problem does exist in basically every ecosystem. About 14% of NPM packages carry known vulnerabilities, either directly in its own code or pulled in from its own dependencies. And roughly 4 or 5, we see users testing their applications. Roughly 4 in 5 users find vulnerable packages the first time they test their applications. So what we're going to do here is we are going to go through an example of a vulnerable application to understand what it is, how do you find these problems, what's the severity of them, how much you should care. And then we're going to ask 2 questions. One is, how do I protect myself? So what are these threats and how do I fix them? And the second is, these are real-world vulnerabilities in real-world software. So they're a really good learning opportunity for us, right? Because we can see great code written by great developers that had a security bug and then got fixed. So we can learn from both the bug and the fix and try to avoid those in our own code. So with that, let me switch over and show you Goof. So this is Goof. This is a live demo, so clearly, it's a to-do MVC app. And you can do things like call mom, or you can emphasize things with Markdown if you wanted to highlight something of importance. We'll see if the Wi-Fi here holds. Oh, I think it's just Heroku refreshing this app. So you can build these things. Then it's a fancy app. It has an about page that just sort of emphasizes how awesome it is. And it's an application. It's a simple Express application. So what we're going to do is we're going to test this application for vulnerable packages and then dig into them. So to do that, we are going to use Sneak. And I just went to the test page, and I will hit test my GitHub repositories, which will typically ask me for some permissions. And there's command line stuff to do all of this as well. But it's prettier here. And you can see that it extracted a bunch of the repositories that I have that use NPM, and it tells me whether or not they have vulnerabilities of a high, medium, low severity. So we're going to look at Goof. So I will dig into the test report over here. And here I can see a bunch of information about these. So this is kind of step 1. It's acknowledging you have a problem, right? This is a find exercise. This is based on an open source vulnerability database that basically we intersect that with the dependencies that you use, and we find whether or not you're using vulnerable packages. So before we dig into the solution, let's understand the problem a little bit more. And to do that, we're going to pick on a handful of these vulnerabilities and show what they mean. What are these vulnerable components? For starters, I'm actually going to use ST. Anybody familiar here? Anybody here familiar with ST? Some? OK. So it's a static resource package that allows us to serve static resources in our file, like our awesome about page, as well as our CSS files, our JavaScript files. And as you can see here, it has a directory traversal vulnerability. Typically, you might dig in and read here, but you've got me, so you don't need to. And when you sort of hear or when you imagine as an attacker that you might have a directory traversal vulnerability, it means you're going to try and break out of the folder from which static resources are found and try to traverse through the directories of that folder. So the first thing I will do as an attacker is I will do some form of .. But if I did this in the browser, then Chrome would, I don't know if you can see this here, then Chrome would conveniently normalize that for me. So you can't really do any real hacking in the browser. And we're going to need to switch to the command line. So here we are. So what we'll do is we'll do curl. This is our about page. And we will see this. And then we're going to try to do .. and maybe etc pass WD, try to get some resource. And if I do this, what am I going to get? No participation. Nothing. I'm going to get some failure because actually Goof looks for the .. So it actually has a security mechanism. It's a smart package. It thought about security components. But it missed something. So if you were fast, you might have noticed that if I do %2e, which is the URL encoded version of this, and I do this, Then, ooh, OK, voila, we got something. So step one, etc stability, by the way, is decreasing in importance now that there's a shadow file. There's a lot of likes there, but it's just an example of something. The other thing that's interesting is, actually, if I did this, if I just removed the file, I will get directory listing. This is interesting. It's another security attribute of the package. It's not a vulnerability per se. Directory listing is, in a package, is just the default configuration. You can turn it off, but it's a bad default configuration. Still struggling a little bit with how do you kind of inventory that, but it's another thing to keep in mind about what are the defaults in some of these packages that you're using. So, just getting warmed up. This is like the easiest hack ever. You just sort of provide the URLs and do this. Let's get a little bit fancier. Next vulnerability I'm going to show is on the marked package. Who here has heard of marked? OK, many more hands. So marked is downloaded, I think, about 2 million times a month. It's a markdown parsing library. It allows us to do these great things like, oh, I said cold beer. That's after a few beers. I should say buy beer. And it allows us to do other things. And specifically, Markdown oftentimes also supports some inline HTML. So if we know that like we see over here, that there is a cross-site scripting vulnerability on this. So what will I do as an attacker to try and exploit that? A script. So I'll just do some script, alert 1/script. And what's going to happen? Nothing, because again, marked has actually a security component in it. It's called sanitize. It is not on by default, but I was smart here. I turned it on. I want to be secure, and therefore it includes those. But there are other ways to get scripts onto a page. You can do attributes, which also sanitize would catch, and there's other ways. Any ideas? The ANSI, whoa, that gets a little bit fancier. I'm a little bit more. So what I can do is I can do a link, an attribute here, right? And I will do JavaScript alert 1. And if I did this, what will happen? Sorry? A typo? Java S. OK, JavaScript. Yeah, so definitely nothing in that case. And nothing, because sanitize, again, catches that. And I could go on and on here for a little while, just because it entertains me. But in reality, this vulnerability, this cross-site scripting vulnerability, is once again related to encoding problems. But this is not URL encoding. It's in the browser. So these would be, what other form of encoding do I have? No? HTML? Entities? So I can do something like this. So I can do, I think it's like 58. I'm going to cheat a little bit and look for, because I have a little bit of a, yeah, 58. So I can do ampersand pound 58 hash, and then I know I'm going to need to put 41 here just for this closing bracket. And what this would do is this is an HTML entity for the colon character. So if I did this, a browser would interpret that as a colon. And what will happen if I do this? Nothing, once again. And again, like, these things can get really, really finicky. So the developers of Marked were, again, they were good. They spent time. They invested in security. And according to the spec, this is how an HTML entity works. So they closed it. However, browsers are far more tolerant than that. So if I go in here and I say add this, then a browser would look at kind of this section here, right, that says ampersand hash 58. It says, you know, like, it's not in the spec, but I think I understand what you meant, right? Like, there's enough hints here that I will just interpret that as a colon. And then it interprets that as a colon. And the rest of that is just JavaScript. So if I just add a valid word in JavaScript, then this would not work. And if I click this, I get the alert. So, like, the reason I'm kind of walking you through this process is it's hard to find these things. You know, it's not really to fault the creator of these packages for missing it. Taking input and understanding all the different paths, especially when that input gets echoed back to the browsers that are very non-standard conforming, is really tricky, is really hard to do. So these are both examples that are a little bit more, well, I guess the first one is server-side, but the second one is a little bit more client-side. Still relatively simple. Let's get a little bit fancier here. And talk about more severe vulnerability. So the next one I want to deal with is Mongoose. Who here has heard of Mongoose? Ooh. OK. So all the rest of you have not heard of MongoDB and Mongoose. So that's impressive. So yeah, Mongoose is the default way through which you access MongoDB in Node. And Mongoose uses an object called buffer. In this case, I'm actually going to click through to the vulnerability information to understand it. And buffer is a very complicated object. It is an object in Node that allows you to allocate memory so you can use it. That's kind of more binary data. And one of its claim to shame is that it takes in 2 parameters, or the constructor can take 2 types of inputs. It can take a string, like you see here at the bottom, which would just allocate the amount of memory needed to store that string. Or it can take a number, in which case it would allocate 100 bytes in memory. But when it does so, it does not zero the memory. So it means this is whatever memory happened to be in that space. And it does so for a variety of reasons, historical, performance, whatever it is, that's the reality of it. And that's true even in today's Node. You can use, in modern Node, you can use alloc safe and alloc unsafe to, like if you use alloc safe, it will zero the memory, but the constructor still behaves the same way. So because of this, it means that if I now somehow, as an attacker, manage to get the information from this buffer, then I can actually read, or sort of get access to a piece of memory that was on the server. And that could include secrets like source code, like keys, like tokens, like customer data. So that's not very good. Let's look at how this works. So in our application, we have a little database model that uses a buffer object to sort of store our to-do items, because it was convenient and it supports emojis and it's good. So we use that and we deploy it. So what we're going to do here is, again, I'm going to cheat because I don't want to start typing all of these, but we're going to use HTTP, HTTPy, and we will do, sorry, exposing a little bit here. But I will do something like this, which is I will invoke the same action that I invoked as part of the posting of the form, but I will do so using a different form of input instead of a form, because this is JavaScript and because we use the body parser and we support JSON inputs into our system. So we will say, echo content fix the bike into this, and I guess we're not on localhost, we're on Heroku. So I'll just fix that. And that's going to add a reminder for us, right? This is very typical. It's kind of one of the beauties of Node. I guess this was from before. One of the beauties of Node that I can invoke all these type of manipulations, right? Like it's very API friendly already, and I can use JSON. But because I did this, then I can now play with the JSON input, and I think this is one thing that was not mentioned in the sort of JSOF talk earlier on, is that JSON is also a tool that allows the input provider, in this case the attacker, to actually control more than what you might think. You may have intended the attacker to provide a string, but the attacker in this case could provide an integer. And if I did that, then that value that gets propagated now throughout the system and gets to the input, to the sort of creation of that buffer object, is not a string, but rather a binary, or rather an integer. And that makes the buffer object allocate this memory. And suddenly this node that just got created has server-side memory. And if I repeat this again and again, and there's no guarantee that it would work here, but if you kind of run this, sometimes you start seeing snippets of code that slip into it and secrets. But basically, if you do this methodically, you'll just get the full server-side memory. So that gets a little bit hairy, right? Memory server, kind of leaking server-side memory is Heartbleed. I mean, it's the same vulnerability that kind of shook the world of OpenSSL, and it's still very prevalent out there. And the buffer-based vulnerabilities exist in Mongoose, in Request, in WS, in a whole bunch of very, very popular packages. So very real issue. I'm going to show one last one very quickly, and then I'll get into how do you fix those and what should you do about them. And the last one I'm going to show is in MS. Who here has heard of MS? No? So MS is actually one that's used a lot implicitly. It's also very popular, and it has a very common vulnerability that we somewhat uncomfortably rank as a low severity, which is a regular expression denial of service vulnerability. a redos vulnerability for short. And what happens here, again, requires a little bit of explanation, but it's interesting for the node space, which is node scales based on threads, based on events, not on threads. So whenever you manage to get an algorithm within Node to run for a long time, you occupy that thread and you keep it from responding to the rest of the system. And the most popular algorithm that you run without even thinking about the fact that it's an algorithm is a regular expression. You match against a regular expression. So in our case, we're using MS to do things like call mom in 2 minutes, and we parse that little 2-minute string, so it would convert that to the number of milliseconds, so that we can in turn set a reminder to call mom in 2 minutes, which we haven't implemented yet, but that's a different story. So we're using a very simple regular expression. But what it means is that it opens the door for an attacker to do something like this. This is, this would be a typical sort of echo. Again, echo the command into HTTP, and I'll just sort of copy the URL from here. Bear with me. Here we go. So, hope you see this enough. So, echo some sort of statement, except what I'm saying is buy milk in, and then I'm printing 60,000 fives in that string. So that would be a long string. And the thing about regular expressions is that they take a disproportionate amount of time to run, like a non-linear amount of time to run as compared to the length of the string. Now, there's nothing in the system that stops me from providing a long string. You have to explicitly do that. So if I do this, then actually nothing happens. Sorry, one small thing, which is regular expressions takes especially long to run if instead of giving a string that matches, you give a string that nearly matches, because just for the purpose of regular expressions, the way they operate, that would take even longer. So if I did this, I do minutia, suddenly it takes a long time. And what's interesting is that in this time, the application is not responsive. So it took up this thread, and this is a single-thread application. And if I added another 0 there, my Heroku build would be really, really high, and this whole system would not operate for a good while. And again, it's very, very important in the node space because Node scales based on events. So even a high production, like a high-volume production system, oftentimes has a relatively small number of threads. So hopefully those are kind of good educational. At some point, this would free up. Let's sort of spend the last few minutes of the talk just talking about addressing this. And I hope I'm OK to sort of take 5 more minutes. I think we started late. The find phase is really the primary way that like you start learning about these things. You become aware of it. And I'm going to show you how to fix it with Snyk, but I will sort of explain the different stages. So with Snyk, what you're going to do is you're going to click a button, and the problems are going to go away. Not exactly, but it would open a fixable request. So we're going to go through that process, and we'll do open a fix PR. And what we will do here in the tool is that it determines, first of all, whether there's a way for you to upgrade the problem away. OK, this is interesting. It's live demos. Let's try this again. It determines, first of all, if there's a way for you to upgrade the problem away. So sometimes there's a new version of this package that has fixed this vulnerability. That's very, very common. And at other times, maybe you're using A that uses B that uses C. So you want to upgrade C, but you can't. We'd figure out like which version of A do you need to upgrade to make the vulnerability go away. So when we can, we will recommend that. And you can see a bunch of upgrade recommendations here in the package.json file. And for the cases where you cannot upgrade, then we take those original fixes and we backport them to old versions, and we allow you to add this Snyk protect hook to your pre-publish step or to a post-install step and provide a little .snyk file. And what this would do is it would take those patches and it would patch those vulnerabilities after they're installed. So if you have that A uses B uses C, C is vulnerable, you downloaded the whole thing, you installed the vulnerable C, and then Snyk protect would run and just make the minimal modification necessary to make the vulnerabilities go away. And you might not be aware of that, but that's the way that operating systems work. If you subscribe to the security update list in Red Hat in Ubuntu, many of these patches are backported versions of the fixes that were created by by Red Hat, by Canonical, that created those. So if I go ahead and I merge this, then these vulnerabilities would go away, and that's awesome, and I'll be secure right now. And then the second question is, how do I stay secure? So first step is fine, second step is fix. The third thing that you need to do is think about prevent, is think about how do you capture code changes This was way too noisy. How do you capture changes that you do that basically catch you before you merge a vulnerable package into your mainstream? So to do that, you can add a sneak test into your build process, and within the GitHub process, you will see something like this. In the pull request failures that says every time you're trying to merge in, you're trying to commit a change to package.json that introduced a new vulnerable package, then you'll see that type of failure, and you can choose whether you want to block it or not. So this is step one. And then the fourth step is, over time, even if your code remains static and it was free of vulnerabilities, it may suddenly have a new known vulnerabilities. It wouldn't suddenly have a new vulnerability. The security flaw would be in the system, but it could be that that flaw was just disclosed. Once it is disclosed, once security research or just somebody on GitHub logged the issue, it's now that much more available to attackers, and attackers are that much more likely to exploit that vulnerability. So there is some sense of urgency once a vulnerability is disclosed, if it affects your dependencies, to very quickly learn about that and roll out whatever fix it is before the attackers have time to exploit it. So to do that, we will monitor the dependencies that you have over time, just sort of listening to changes to the commit. And when there is a new vulnerability that gets disclosed that affects your dependencies, we will send you an email, we will send you a Slack notification, but we'll also send you a fix PR with the fixes necessary and all the information. So I guess coming back here to just do a quick recap. First of all, coming back here says, don't start hacking websites out there. It's definitely illegal and either more or less so impolite. These are 4 examples, but basically as you go through snyk.io/vuln, if you look at the vulnerability databases, this is an opportunity for us to learn from vulnerabilities in open source packages and understand how is it that they can educate us about how we write our own code in a secure fashion. These are just some of the examples we had here. And then lastly, for the packages themselves, think about how do you find the vulnerabilities today, how do you fix them, how do you prevent adding additional vulnerable packages, and how do you respond quickly when new vulnerabilities come out. So, hope you guys are awesome. Please enjoy responsibly. Thank you.